Thank you for the warm welcome. My name is Hautakangas, and today I'm going to talk to you a little about malware development from a script kiddie point of view. But before we get to the actual presentation, here are a few things about me. So some of you might know me by my nickname, Annenaattori, and I have a day job at Insta where I work as pen test lead. It means that I'm basically like a project manager for a small group of pen testers, and at the same time, I get my hands dirty with the actual pen testing as well, which is the absolute best part of my job. My background is I used to be a front-end developer when I started my career, but then I got tangled up with some business-related stuff and kind of lost my soul until I was saved by Helsec, future female, and cybersecurity in general, and now I'm enjoying my time here in the darkest corners of IT with all of you people, and it feels like home. On my free time, I like to humble myself by doing HEMA, which means historical European martial arts. I'm no good at that, but it's an excuse to own swords and spears and, you know, the cool stuff. I also do some volunteer work for Women for Cyber Finland, and I'm, of course, a Girl Scout, because I'm a nerd. But let's get to the actual presentation. My goal today is to show you what kind of things can be achieved in malware development when you don't really know anything about the topic, you don't have any money, and you don't really have a lot of time either. I did this project during my Christmas holiday, so the time that I had was week and a half, so not much. I decided to do this project because I realized one day that I just really don't know much about malware. I know the different types of malware that there is out there, and I try to understand and do my best in avoiding malware, but I don't really know what happens when a machine gets infected by malware. What does it do inside the machine? I had no understanding of that. And I bet there are people in the audience who would just say that, go read a book, but I've been with myself for roughly 40 years, so I know that the best way for me to learn is not to read a book. I just don't learn that way. The best way for me to learn is to get my hands dirty and just do something, and that's why I created a tiny, tiny piece of malware. Before we get to the interesting part, let's talk about crowbars. I have a friend who is a police officer, and we often, when he comes to visit, we talk about our work, and those are also always a bit funny discussions, because he can't really talk about his work, and I can't really talk about mine. So we just talk about the things surrounding our jobs, and that's typically things that are illegal or illegal, and things that might be either one or the other, depending on minor details. And he told me this great metaphor about crowbars, that it's not illegal for anyone to manufacture a crowbar. It's not illegal for anyone to buy a crowbar. If you have the funds, you can have it. But the second you use the crowbar to break into your friend's home, that's when you're committing a crime. And it's the same with the skills and the tools that we use, the stuff that you will learn from this presentation. You can use it to break your own stuff, but please don't take over the world with it. It's not meant for that. Like every project, mine started with research. And like I said in the beginning, I had zero knowledge. I was starting from Google, searching information about the different type of malwares that are out there. And what I was looking for was something rather simple, something rather easy that I could do. Very soon I realized that it's not enough to just do malware. There needs to be some antivirus evasion stuff too. Otherwise, it's just not going to work. And when I was looking at all this from a developer's point of view and thinking about that I have that 1 week, 0 cache, 0 knowledge, it's an impossible combination. It's not going to work. I'm not going to be able to digest everything and then develop the thing. But this desperation is also when the script kiddie inside of me awakens. And for a script kiddie, this is a pretty simple problem to solve, because there are really just 2 requirements in all of this. The first one being that there needs to be plenty of tutorials. Whatever path I would choose, I'm very dependent on tutorials, so the more, the merrier. And the other thing I chose to be, or thought to be important, was that whatever techniques I choose to use, it's great if they are currently and successfully being used by criminals, because it means that it works. Otherwise, they wouldn't be spending their time and their effort into these things. And the holy grail of script kiddie malware development that I found was method or technique called DLL sideloading. Now, if you don't know what DLL sideloading is, we're going to go through it in a moment. But if you're a bit more technical person, here's a great white paper by Palo Alto Networks that explains pretty much everything there is to know about it. And it's the white paper that got me convinced that this is the right way to go if I want to do something malicious like this. But let's look at this DLL sideloading. What does it mean? Let's look at it first from the user's point of view. So I've created here a phishing campaign, and the user has received an invitation to a party. It's a very exclusive party, so of course they will open. And because it's an exclusive party, there's going to be hotel reservations, restaurant reservations, transport. It's complicated. But the organizers are very organized, so they have built this package of information, and you're expected to download it. So the user downloads it. Inside is a PDF-looking file. They click on it and live happily ever after. From the attacker's point of view, things are a bit different. When user clicks on the PDF-looking thing, it opens up not a PDF, but actually a copy of a legitimate Windows software that came inside the zip file as well. I saw tutorials that were using pieces of Discord, Notepad++, certain Microsoft software. The meaning here is that it's rather small in size and uses dynamic link libraries, DLL files. Because whenever a program is executed, it's going to look for the files that it needs, and DLL files are the ones that we are going to abuse in this technique of ours. And if you don't know what a DLL is, it's basically this library of code or data sets, things that the software requires in order to run. And typically, DLLs are stored in Windows System 32 folders. But Windows has this rule that if a DLL is in the same folder as from which the program is being executed, the program will use that DLL. So inside the zip file, we have had so far the PDF, a tiny, completely legitimate Windows program, and a DLL file that has the same name as the program wants or is looking for. Now, this DLL is malicious. This is the one that the malware developer has developed. It doesn't contain the code, the data that the program is looking for. The problem here is that in order for the malicious code to be executed, the program needs to be kept running. And in order to do that, the first thing that the developers do is that they insert in the beginning of the file some guidance on how the program can find the pieces of data or the functions, whatever it needs. And typically there's another copy of the file or copy of the real DLL file that the program is looking for inside the zip file. Now the program is running, it found the stuff it needed, and it's going to execute the malicious code. And the malicious code basically just loads up a payload and contacts the bad guys. If we look at the real-world situation of this, because this is kind of a core concept of all this, so I really want you to understand this. So here we have the party invitation, but if we look at the hidden files inside this folder, we see that there's plenty of other stuff. There's the malicious, the completely legitimate Windows program, a DLL that it's looking for, but it's not the DLL that it's looking for. It's a malicious DLL, and we guide the software so that it finds the stuff that it needs in order to run, and as it's running, it's executing the malicious DLL and our payload so that we get a connection. So on paper, that seemed, well, not maybe simple, but simple enough that I was able to understand what I was trying to achieve here. And from that, it was time to start the development. Now, what I didn't know was that DLLs, typically, they are made of C++, and I had zero experience on C++. So what I ended up creating is it's a true monster. It has bits and bobs from here and there, and by some miracle, it's working, it's running, even though, yeah, it was awful. I'm glad it's over. But I had a lot of help from tutorials. There's this thing about, well, I don't have a lot of experience, but it seemed like in malware development, the tutorials expire quite fast, which is great in a sense. But if you find a tutorial that is 2 or 3 years old, it probably doesn't completely work anymore. But here are a couple of ones that I found very useful. So Dominic's tutorial explains kind of from the beginning to the end how to create malware. His tutorial was using Notepad++. I wasn't able to get his example to work because I had already committed to a bit different path of doing things than what he was doing, but his way of explaining things is really, really nice. So I do recommend that tutorial, even though I didn't get it to completely work. CryptoAce has a lot of blog posts on malware, and he has this one specific blog post where he explains how to find software that can be exploited this way. And that was really useful, and he has some ideas on how to improve this kind of malware even further. Now, neither of these tutorials really touched upon the antivirus evasion stuff, so that's an example of things that I had to come up with some way else, in some other way. And for me, the easiest way was to go with the one that seemed the most simple and just delay the execution of the malware in case the antivirus software grabs the malware and starts looking at it. It's delayed for a moment, it pretends it's not doing anything, and we kind of just hope that the antivirus software releases it before it starts doing the nasty stuff. Now, if we dive deeper into the code, we remember that the first thing that happens inside the malicious DLL is that it redirects the legitimate software to the things that it needs. The next thing that happens is that it lists all running processes in Windows. And we do this because we don't just want to hide inside that legitimate Windows program. We also want to hide inside some legitimate Windows process, so that if antivirus is looking at us, it's only seeing things that should be there. And in a lot of tutorials, it seemed that they were using runtime broker as the process they were taking over or piggybacking into. I'm sure there are other processes, but you know, I'm a script kiddie, so I follow where the tutorials lead me. Once we have found the runtime broker, we buffer the payload, and we use the runtime broker to make a system call to NTDLL, which has the capability to open and start processes and just make the way for us to contact our post-exploitation tool on another machine. And the last step is cleanup. We don't want to leave any trace of what we have done. So we have done research, we have done development, and the last thing to do is pick out the post-exploitation framework. Now, if you don't know what that is, it's sort of the receiving end of the attack. So when the victim's machine is infected, it needs to connect, and the easiest way to manage the connection is to have a framework on the other side that has these scripts and everything ready that you can use without doing everything by yourself, by hand. There are quite a few options. I think Cobalt Strike is the most famous one. It's also very expensive, and this was a zero cash project, so I couldn't afford that one. But I found a lot of nice tutorials about Sliver, so that's the one I ended up using, and it worked just fine for the purposes of this learning project. Now, we have the research, we have the development, we have the post-exploitation framework. So it sounds like we have everything we need. Would you like to see a demo? So, in the left-hand side, we have a HTTP server running on the attacking machine. And we are starting Sliver. And we instruct it to listen to a certain port, 8888 in this time. And then we go to the victim's machine, and we pretend here that the victim has received an email, is going to a web page, it's a party invitation, and all the cool people are already going. Oh my gosh, of course we're going to download the instructions. We got to go. My apologies for the language of the user interface. Mistakes were made, but we extract it. And as you can see, there's just a party invitation, but if you remember from before, there should be a bit more in there. And there are actually a few extra files here, as you can see. This is due to the fact that this was done during Christmas time, and Microsoft has already improved things, so what I did then doesn't work exactly the same way. So malware developers' life is so hard, which is good. The user is now clicking on the file. There's a notification here because I don't have internet connection here. It's trying to check the signature of the OneDrive updater. If you have internet connection, this notification will not be there. It's waiting for a moment. That was the delay. And if we go to the attacker's machine, we can see that there's a probe that we just received. We will now activate the probe, or the beacon, sorry. and instruct it to take a screenshot of the victim's machine so that we can see what's going on in there. There are a few neat options in Sliver what you can do with just basic one-line, one-word commands. Now we are on the victim's machine again. Let's see how our defense looks, because we just downloaded something off the internet. There's an alert because no internet connection. I'm not logged into OneDrive, but everything looks good. I think we're safe. And if we now return to the victim's machine, this will take a while because these beacon tasks are slow. But here is our screenshot. And if we go to the temp folder, and open it up, we have a screenshot of the victim's machine. So these were the results. Typically, when I ran this against any antivirus software that I was able to get my hands on without giving out my credit card information, the antivirus software found all kinds of things wrong in my system, but it didn't find the malware. And this got me a bit worried because I'm not a real developer. I don't really understand much about C++ or Windows processes or anything of that. So it was a bit scary that it was so easy. But then I also realized that I wasn't really trying to be malicious, because if I would have been really developing software that I would have wanted to use against someone or some company, I would have to think things a bit differently. Starting with the post-exploitation framework, Sliver has been criticized because it creates big payloads. The payload is, I think it's 17 megabytes. And that makes the entire malware package to be around 30 megabytes. And you're trying to pretend that you are just a single PDF. It's not very credible. I think that real malware developers also use a bit more complex evasion techniques. I was only using the delay, and I jumped on a different process, but there are better techniques than these. And at the last bullet point there is the fact that I didn't do the kind of stuff that malware typically does. I didn't try to build persistence or privilege escalation or anything like that. I just took a picture, and I was happy with that result. I maybe did some browsing in the directories, and that was it. It was enough for me. I'm sure that if I would have attempted something like this, Sliver has capabilities for this kind of stuff too. But I think that if I would have tried something like that, there would have been a flag raised somewhere. Well, lessons learned. I learned definitely a lot about malware development and how malwares work. So in that sense, a goal was achieved. It also emphasized the meaning of cybersecurity in a sense that you can never trust the world's best antivirus software on the market. Cybersecurity needs to be in layers, like we all know. I also learned something else related to operational security. Operation security means that you should never leave behind anything that could reveal who you are or anything like that. But it's a little embarrassing story. Do you want to hear it still? OK. Well, it was the Christmas holiday when I did this project. And when I returned to work, I, of course, told my colleagues and my manager that I have built this malware, and I think it's cool. It would be nice to show it to you. And my manager is a really nice guy in a sense that he gets easily excited. And he told me that, yeah, let's bring it in, let's put it in a lab and make it run on a machine. And it turned into this sort of purple team exercise where we had a machine that was infected by the malware, and then we had the security operation center people running around in circles around the machine to try and figure out what was wrong with it. And it was a lot of fun because for my entire cybersecurity career, I've been on the offensive side. I've never seen how the defending side works. And I didn't really know what kind of things they were able to do and see. And one of those things that I didn't know was that they can check the metadata of a file, and they can see where it originates from. And guess what was reading in that cell over there? I don't know who's behind this thing. I have no idea. Yeah. Well, it definitely doesn't read like that there anymore. So what's next? This was really fun to do. I learned a lot. Insta, my employee, also got a bit interested in this. And I'm really hoping that I could develop this a little further. And if that happens, maybe I'll come here again and share with you what I have learned. But this was all that I had for you today. Thank you for having me, and I think we have some time for questions if anyone has any.
Yeah, if you have any questions, please just raise your hand and you will be given a microphone to ask the questions. Any questions?
You can save the hard ones for Mikko and Markus.
Yeah. I think, yeah, we got one over here.
So question, what did that malware actually try to do? Did it try to do something that would be suspicious? And if it did, would that actually get flagged by the virus scanner?
Yes, I think that's exactly the point. The malware only opened up that channel to the attacker's machine, and from there on, the attacker can decide what they want to do. Now I only took screenshots and I browsed some directories because that was very exciting for me already. But I do agree that if I would have tried privilege escalation or something like that, then the antivirus software probably would have alerted.
This one in the front, yeah.
So how did you circumvent this signature validation from Microsoft that you showed that if there was internet, you wouldn't see that, but how did you circumvent the signature? Because you probably modified something.
Good question, because I was supposed to explain the notification and I didn't explain it. So if there is an internet connection, the Windows is able to check the signature of the software. But the trick here is that the software that is checking is OneDrive Updater. And Windows has that signature in their database, and it's flagged as secure software. And that's the reason why the software that we use in this DLL sideloading technique, it needs to be something that Windows knows and recognizes, something part of Discord, Notepad++, something familiar so that it doesn't get suspicious about it.
Okay, so basically that signature validation doesn't include this DLL thingy that you did.
No, it doesn't. It doesn't alert that. Yeah, there is obfuscation for the payload. So the payload itself is encrypted as well, so that if the antivirus for some reason starts to be suspicious about the payload file and tries to look into it, it can't see the source code. It has been encrypted, and the encryption is decoded when the payload is executed.
Yeah. Thanks. Nice presentation. Thank you.
Any more? I think we are. Oh, still one more. Yeah. OK. Let's have this one, and after that, we will have a break. But yeah, one more.
Yeah, did you try without the delay first?
Yeah.
And it didn't work?
No, I didn't actually try without the delay because I thought that some kind of antivirus evasion needed to be there. And the delay was the easiest thing for me to understand. But it's a good point, and maybe something I could try out to see if the delay is needed, if the piggybacking runtime broker process part is enough of evasion. I don't know, but it's something that I will test.
I suspect it will work.
All right. Thank you very much, Anne.